Hello. Thank you so much for joining us today. Just wanted to make sure that you are able to hear us. Awesome. Cool. Thank you. So in this session, we'll talk about how Amazon generates threat intelligence and how it is used to protect your infrastructure in AWS. My name is Salim Mohammed. I've been at AWS for 3 years. I started by managing Amazon Elastic Container Registry, where I also launched an open source container build project called Finch, before joining Network and Application Protection, where I manage firewalls. Prior to AWS, I used to manage various storage, networking, and private cloud solutions at companies like Dell Technologies, Brocade, and Cisco. With me, I also have Will.
Hi, my name's Will. You want to switch to the next slide? My name's Will Bowditch. I've been at AWS for about 2 years now. Before Amazon, I did threat detection at SecureWorks and then research and advocacy at Rapid7. I'm now a security engineer on the perimeter protection threat research team, kind of balancing both security and software engineering hats during my time.
Thank you, Will. To review our agenda, we'll first talk about how Amazon leverages its scale to generate threat intelligence. Then we'll talk about some of the initiatives that we have publicly disclosed so far. Then we'll go and take a deeper dive into one of those tools or initiatives. We'll also share 3 examples of how we are using the threat intelligence using one of those tools. And then we'll close the session by sharing how you can use this unique threat intelligence to protect your workloads using some of the firewalls that we offer within AWS. The scale and size of our infrastructure gives us unique visibility into the traffic globally. Every day across AWS cloud infrastructure, we detect and successfully thwart hundreds of cyber attacks, which might otherwise be disruptive and costly. These important but mostly unseen victories are made possible by our global network of sensors and associated disruption tools. These sensors observe more than 700 million threat interactions every day, out of which approximately 450 million advance to a stage where they can be classified as malicious. A major part of protecting AWS infrastructure is our threat intelligence capabilities and proactive mitigation mechanisms. The goal of these initiatives is to drive down threats by driving up the cost for malicious actors targeting AWS. And it also puts us on the front foot in maintaining the availability of AWS and your workloads in AWS. The threat intelligence that we generate is used in multiple ways. First, it is definitely used to protect AWS infrastructure and your infrastructure in AWS. For example, in last 12 months, we were able to successfully detect and restrict approximately 27 billion attempts to discover unintentionally public S3 buckets and about 2.7 trillion vulnerable services on EC2. Another way we leverage our threat intelligence is by collaborating within the industry to make the internet a safer place for everyone. An example of that is about 80,000 takedown requests that we issued in last 12 months to disrupt the network and infrastructure of malicious actors. And a third example of how we leverage our threat intelligence is by collaborating with government agencies. An example of that is Anonymous Sudan, where we collaborated with government agencies to create the signatures and disrupt these threat actors, which ultimately resulted in an indictment by Department of Justice. Customers like you increasingly ask us where our threat intelligence comes from. How is it, what type of threats do we see, and how do we take action against those things that we observe? And lastly, what is it that you as a customer can do to protect your infrastructure in AWS? While we are involved in a number of threat intelligence gathering activities, there are 3 major initiatives that we have talked about publicly. Those are MadPot, Sonaris, and Mitra. With MadPot, we are able to discover and monitor malicious activities and disrupt wherever possible to protect our infrastructure. MadPot is a network of honeypots or digital decoys that keep on evolving and changing its tactics in an attempt to observe the tactics, techniques, and procedures of malicious actors. The intelligence that we gather through MadPot is used in AWS Shield to protect our infrastructure against DDoS attacks. It is also used and converted into AWS managed rules that are available to you in AWS WAF. And also, it is used to generate customer findings in guard duty. The second tool that we have publicly disclosed is Sonaris. With Sonaris, we are able to detect and restrict abusive scans and exploitation attempts. Sonaris, through integration with MadPot, is able to identify malicious activities with a higher degree of confidence. Sonaris will only intervene when it has a high degree of confidence that the threat activities that we are observing is indeed malicious. Besides taking automatic remediation actions, we also use that threat intelligence to create Amazon managed rules that are available to you in WAF, as well as Route 53 resolver DNS firewall. And the third tool is Mitra. With Mitra, we are able to identify with high confidence malicious domain list, which is used in guard duty to generate customer findings. Mitra is our neural network graph model that uses algorithms to generate threat intelligence. With its 3.8 billion nodes and 48 billion edges, Mitra is able to identify malicious domains with high degree of precision. And it can do so sometimes days, weeks, and months before those malicious domains appear on external threat intel feeds. Our threat intelligence sits at the core of network and application protection suite. As I was highlighting, one of the main places where we use this threat intelligence is to protect AWS infrastructure. We also use the same threat intelligence and convert those into AMRs, or AWS managed rules, and give it to you in our firewalls for network and application protection. And lastly, we have a centralized management tool called Firewall Manager that you can use to manage firewall policies centrally across the globe to meet compliance. With that said, now we're going to go and take a deeper dive into these threat intelligence capabilities. Will, please join me.
Thanks.
You can click.
Cool. Nice job. Hi. So again, I'm Will. Sorry to start with a definition slide. It's sort of like a bad best man speech, but I think it's important to define what threat intelligence is, because I think these words could vary depending on the context and the organization. So for us, threat intelligence is the process of gathering, analyzing, and applying threat data about potential or active cyber threats to enable proactive and informed security decisions. We believe that baked into this definition, threat intelligence needs to be contextual, meaning that, for example, if you were to say an IP is bad, or say you have like a URL that's hosting malware, you don't want to jump and just say like the domain is bad or the domain registrar is bad, because that can lead to ineffective mitigations at best or obtrusive downtime at worst. On the flip side, if you give someone all these TTPs on like an advanced threat group, but they don't have the means of applying this feed, they might not have the security posture, the maturity to apply it effectively, that's not going to be helpful either. So it needs to be actionable. So my team's vision is to use threat intelligence to create this virtuous cycle that accelerates Amazon's defensive and accurate security measures. We do this by gathering threat data on signatures, artifacts, and indicators for internal Amazon teams on emerging threats, common vulnerabilities, cyber attacks like DDoS or credential stuffing or ransomware, and intelligence on threat groups such as ransomware gangs and advanced persistent threats, APTs. The analysis of this threat data then results in first-party verifiable intelligence, meaning that we have the receipts, we have the paper trail, so we can trust this on threats targeting AWS and the internet at large. So why is threat intelligence important? it's important for your org because just as your organization and business is evolving, so is the threat landscape. If I just give you like an IP set and I say these IPs are bad, or I give you some feed, that's going to get stale really fast as actors adapt and change their tactics. Your org is unique, and I'm not just saying that to compliment everyone. Your org is unique, and you have a specific vertical and tech stack, and there's a lot of different threats. And you need to focus on the threats that are targeting your specific vertical, which allows you then to do efficient resource allocation on the limited time you have. Lastly, threat intelligence is really cool because there's an act of collaboration and sharing. It's like getting different pieces of the puzzle for different orgs. And there's an opportunity for knowledge sharing as you work with other parties, and in some cases, law enforcement to take these threats down. So how do we start gathering threat intelligence? One approach is to work backwards from threat targets, such as post-compromise, so after recovery from an incident. This is going to give you loads of artifacts on the threat, which your team can then do analysis on. And then since you have the context, you're able to create threat intelligence, which you can use then to mitigate threats in the future. Obviously, this isn't the ideal scenario. You don't want to wait until you've been popped before you can start mitigating threats. Furthermore, from Amazon's perspective, working backwards from threats presents significant challenges with privacy concerns and data ownership issues. It would force us to rely on info gleaned from compromised customers or compromise ourselves, placing us in this difficult position of depending on misfortunes to gather intel. So our team believes that the best defense is a good offense. So rather than solely working backwards from today's known attack signals, we prioritize research into anomalous signals from our threat monitoring and tracking mechanisms to discover novel threats targeting the cloud. That's why we now have a focus on deception technologies to give us deeper insights into more threats sooner. Deception technologies are an approach to security that relies on decoys and traps to attract and engage, deceive threat actors to reveal their tactics, techniques, and procedures. One of the key advantages of threat deception technologies is its ability to provide us with a narrow, focused scope of data. Unlike traditional security logs, it can be overwhelming in volume. Threat deception gives us a much smaller, much more concentrated set of data to work with. This is because the system is designed to attract only malicious actors, effectively filtering out the noise of regular telemetry. So as a result, when we detect things in our deception systems, we can be fairly certain it's worth investigating. Furthermore, deception tech allows us to harvest threat data across all attack stages. So during reconnaissance, our decoys can detect scanning activities, revealing what actors are looking for. As actors move towards weaponization and delivery, honeypots can capture the malware and other artifacts, which then we can analyze with reverse engineering and some static analysis, some sandboxing. You have installation techniques that you can see to see how actors are trying to establish persistence on the device after the door's been closed. And ultimately, deception tech can reveal what the actor's end goal, whether it be like system disruption or ransomware or data exfiltration. Deception also allows us to disrupt actors at the source. So by engaging with our deception environment, they're revealing little pieces of their dedicated infra. And these artifacts as threat data that enables us to attribute the attack to specific threat groups or actors. And so in some cases, this info can be shared with external providers as well as law enforcement to combat these threats on a global scale. And then lastly, threat deception is adaptable and scalable. It can be customized to fit like the specific needs and infrastructure of any org, no matter the industry. What's really cool is that deception tech doesn't need to necessarily be running in your production infrastructure. It can be separate. It can just look like you, which allows you to continuously modify, change, and scale this deception system without impacting your actual production business needs. So there's different types of deception tech. I'm going to kind of go through them. They kind of all work together, but there's different terms people use. So baits and lures are kind of the pieces of information, the artifacts exposed that attract actors. That might be like a flashy HTTP title for a service that just got vulnerable, some funny domain names that might be related to critical systems, stuff like that. You have honey tokens then within those, which are fake digital entities like certificates or creds or files. These are things that might be like a canary in the mine, where when you see interactions with them, you might see someone try to use those creds that can fire off a signal that no one should be touching these. Finally, you have honeypots, which are then the decoys and systems that are being exposed on the services, exposed in the internet, or in your turtle system, emulating like a plethora of different services. You can have low interaction honeypots, which might be just like answering to the weak probes, all the way to like high interaction honeypots, which are the legitimate service down to like the hardware. These technologies then like work together to build this threat deception flywheel. So as attackers interact with their tech, we gather intelligence on them and we use it to refine our deceptions, making them more convincing and effective over time. So an example, if a threat actor is looking for a specific path or file, we can then go in and say, oh, this is what they're looking for, and start kind of modifying our honeypots to track it so that it verified that the vulnerability is there, and then they go for exploit. So this system kind of transforms your network from this passive target into an active defense system, constantly learning and adapting to the evolving threat landscape. So by deploying these various deception technologies in your infrastructure, you're creating this dynamic responsive defense capabilities. So MadPot is a public example of one of the ways that Amazon uses threat deception to discover emerging threats in the cloud. It's something we disclosed last year, and one that I'll kind of be elaborating on different use cases during this talk. So to take a step back on why threat deception in MadPot is important. Let's say you're building, crazy idea, you're building something in AWS and you want to expose that as a web app, and then there's a hiccup, you haven't caught up to date with like the latest common vulnerability exposure, CVEs that are on the internet, and now you've released out a vulnerable server. How quickly do we expect this service to be compromised? Well, on average, as mentioned before, within 90 seconds, you're going to get a probe on that server. That's like a knock on the door or a peek through the window to see who's home, see what's running. Then, within 3 minutes, you're going to have an active exploit against that server. So how do we know this? How do we have this number, 90 seconds as opposed to an hour? And that's because across the AWS network and around the world, interspersed within public IP address ranges, we run a fleet of decoy sensors emulating a variety of different applications and protocols. So this means that when bad actors are enumerating our perimeter for your resources, they're stumbling into our traps instead. So in cybersecurity, we talk about these as honeypots, and in Amazon, we refer to these fleet of honeypots, a deception system, threat intelligence gathering platform. It comprises as MadPot. MadPot's architecture was built with several crucial design principles. I can't go way too in the guts, but I think these ideas kind of carry. So development and agility. So I work on a team that's both security engineers and software engineers working hand in hand. This is a system that needs very fast iteration. As new things come out, new things change. Related to that, we are a research team. So that means experimentation is built into MadPot, right? We're trying to optimize for maximizing engagement with threat actors. They give us indicators that allow us to help customers. So there's a constant balancing and measuring act there. Realism and stealthiness, right? We don't want it to be easy to pick MadPot out of a crowd. There's a balance between exposing MadPot everywhere and taking over everything and having it more stealthy and realistic so that a threat actor that might not be a bot, it might be hands-on keyboard, can be deceived by this. Getting payload signatures and annotations. So we have annotations and classifications on the different interactions that come in, and we need to trust these interactions classifications due to our downstream customers relying on that when we talk about the verifiable first-party data. And annotations, getting things like, what can I think of? You're breaking down the HTTP payload and getting maybe like a TLS SHA-3 from it, looking at the user agents, the cookies, the order, stuff like that. Finally, we also then have threat artifact extraction and storage. So this is when we see links maybe in this remote code execution payload, it might try to call out and download something. We're gonna go fetch that. If there's some embedded drop in like a Postgres query, we're gonna go base 64 deobfuscate that and pull that down and then store that safely for further analysis. So MadPot is by no means the only source of threat data that Amazon makes use of, and there's still a lot of analysis to be done. So this analysis involves probing potentially malicious resources to validate suspicion, detonating that malware and seeing what it calls out to, tracing this net flow to increase coverage. So this work results in threat indicators that can effectively be consumed for mitigation and disruption by like AWS Shield to do null routes, basically blocking communication with this bad stuff. AWS WAF, so some of the AMRs, the managed rules that we put out, Amazon guard duties, so doing different findings that pop up when your infra starts talking to this bad stuff, and then takedown requests, both internally and externally. So backing up, MadPot is this global honeypot fleet that receives TCP and UDP traffic on tens of thousands of IP addresses every day. It emulates hundreds of different services, from Postgres to SSH to RDP to specific HTTP applications. It's also mimicking the fingerprint of commonly exploited devices like IP cameras, small office home routers, stuff like that, VPS software, all with the goal of attracting engaging threat actors, trying to get them to reveal TTPs. And ultimately, all of this data and intel is being fed to dozens of teams and services. So we're going to talk about some use cases, starting with protecting customers from botnets. So botnet C2 anonymity and decentralization enables a lot of diverse attacks, making threat mitigation extremely challenging for defenders. It's not as simple as just, hey, I saw a botnet, I saw those IPs, I blocked it. That's not going to solve the problem. So MadPot, though, attracts and engages with these botnet C2s, enabling AWS to proactively disrupt and take down these botnet operations. A botnet, right, is a network of compromised devices, commonly referred to as bots or zombies that are controlled by a threat actor. The process begins with the actor acquiring a host machine as scanners, typically through illegal means. The actor then uses these machines to scan the internet, identify vulnerable devices to interact with. They might use some like public attack surface management tools that I won't name to kind of search for exactly what they're looking for, monitoring cert transparency logs, or they're just like enumerating IPv4. So once vulnerable devices are identified, the actor infects it with malware. Then this malware is typically designed to self-propagate. So each device will attempt to infect other devices and encounters, and this approach allows the botnet to grow really rapidly. And it should be worth the note that these botnet operators are competing with each other. It's a business that's completely on the side. So they race to infect as many devices as possible, aiming to build the largest and most powerful botnet. So this competition drives the rapid expansion and the evolution of different botnet families. So now let's say this bot has attempted to spread the infection to MadPot, to a MadPot sensor, possibly imitating the same vulnerability that caused its own infection. So believing that the sensor is vulnerable, the bot sends a request containing some remote code execution, attempting to curl some dropper. If we were to follow that chain and run this extracted dropper, it might be like a bash script. It calls out to a distribution server where the actual malware is hosted, a botnet malware. Then if you were to run that botnet malware, you'd be able to see that calling out to the command and control server. Then let's say we have some other system to basically confirm and identify what the C2 server is doing. What can we do with this within Amazon? So while we provide customers with a bunch of resources to run secure applications like AWS WAF, Network Firewall, Guard Duty, I don't want to miss any, but we don't force anyone to use them. So some developers may not follow AWS best security practices, leading to their instances being compromised. We don't want compromised instances to be involved in attacking customers or other targets. Beyond the impact to the actual target, it's also bad for Amazon's IP reputation and the resources, and just bad for the internet overall. So what we can do is, now that we have identified the C2, we can cut off access to it across AWS networks, ensuring that even if an instance is infected, it won't receive attack commands. There's also other work with our team that feeds in and helps these customers out that are infected, but there's a lot to talk about. So this threat intel we capture is not only useful for AWS, but also for the security of the wider internet. Like this command and control server is hosted on another hosting provider that probably does not want that C2 running there. It most likely, I won't make any claims, was taken from an account that was stolen, but this is dedicated infrastructure for the actor. So we share, with all this intelligence we have and all this proof, we then go to the external hosting provider to help them take down this data. They take down this command and control server. So one example I'll go into of how we collaborate. There's other things we do collaboration on besides botnets. But one recent collaboration that's exciting that we can talk about was on October 16th, the US Department of Justice unsealed criminal charges against leaders of Anonymous Sudan cyber criminal group and acknowledged Amazon's contribution to the effort, which led to the takedown of the dedicated infrastructure abused by this group to carry out distributed denial of service DDoS attacks. So in the last 12 months, we've requested more than 2,500 hosting providers and domain registrars to take down more than 80,000 distinct hosts and domains. So when service providers take down attack infrastructure based on our requests, the actor needs to reestablish the new infrastructure, which takes time and money. So our takedown requests increase the cost of operation and business for these criminal groups, which makes it less profitable. Anonymous Sudan is one of the dozen DDoS as a service, it's a new as a service term for you guys, that helps AWS disrupt, that AWS has helped disrupt in the past 2 years. So our tools enable us to continually trace the DDoS attacks that Anonymous Sudan claimed publicly. Anonymous Sudan targets were like a spread of different sectors from healthcare, hospitals, e-commerce, government, streaming media, and telecommunication. To carry out these attacks, Anonymous Sudan used servers hidden behind proxies on the internet, but MadPot enabled us to identify the group's attack infrastructure origin, collect info needed to confidently attribute attacks to Anonymous Sudan, and then provide information to the relevant organizations hosting this infra so they could take action. This basically helped hosting providers and industry partners in triangulating key components used by this terrorist group. Pretty cool. Moving on to the next case, and that's just one example. We can talk more afterwards if we want to go into other ones. Protecting customers from malware. Malware distribution networks evolve, change. You have to keep up with what's hosted there. And as you said before, right, we stop these DDoS attacks, but there's still, there's potentially then Amazon infected bots that are still living and coexisting, even if we block that C2. So MadPot's able to identify the malware hosting and distribution points, enabling AWS to preemptively disrupt downloads to AWS resources. So I'm going to go into CUPS. It's an RCE, unprivileged zero-day, CVE 2024, 47076 that I think came out in September, October. We can talk about it in a little bit, but there was a lot of hype for this CVE in the weeks before, saying this was a big 9.9 CVS score, and I'll kind of walk through what this is. But that didn't happen to be the case. But anyway, CUPS is the common Unix printing system. It's a printing system for Unix-like operating systems. It basically allows your Linux server to act as a print server, accepting jobs. I know everyone wants to run printing servers on Linux. That makes a lot of sense. But basically, it allows you to accept jobs and send them to the server. So CVE 2024, this one, 47076, was a vulnerability that allowed any arbitrary actor, if the CUPS server is exposed on the internet, to send this UDP request that basically says, hey, add this printer, this URL as a printer, add this server as a printer. And this is already kind of cool, besides from the malware infection. If anyone's familiar with different types of DDoS attacks, you're sending a UDP request, and out comes a post-HTTP request, basically the CUPS server saying, hey, let me get information. UDP you can spoof. This is an example of an amplification attack. It's a really small payload to a big one. But anyway, this then actor's fake server, right, that they control, then there is an unvalidated printer attribute command. So it's not sanitized, meaning the actor can get arbitrary code to run in the server attributes, as the server is supposed to say, hey, what am I? What do I do? Let's say it includes it's in a specific protocol, the internet printing protocol. It calls out to try to download a malware bin. And then it's not until a normal user sends a print job that then the print server says, hey, who are my printers? And it then runs that remote code execution, that arbitrary code. So it's not immediate. It's not until a user sends a print job to the server. And then the idea is that then the malware would get called down, that wget command would be run. So the reason I gave this preface is that we try to follow the data rather than the hype. So this requires a print job for remote code execution to execute. There are not many legitimate Linux print servers on the web. And we know this because if you start looking for CUPS servers, which a lot of people did, they're going to stumble into MadPot instead. And so we can see that minimal network activity to these distribution servers. You can see there, the CVE is still waiting analysis. It was not 9.9. But this is an example of, instead of just following what we see online, we have the data so that we can resource and allocate ourselves correctly. And again, MadPot's able to pull this down I pressed back, sorry, one sec. MadPot's able to pull this down, emulate that same request, emulate that quest out. It sees the UDP. It knows about CUPS. It sends out that post request. And then MadPot doesn't have to wait until a print job happens. It just sees the actor printer send that malware or send that code in that printer registration payload. And then we have the artifact, and we have the server, and then that allows other internal teams to then block that malware distribution server. So the big point here, though, is that aside from cups, even though it was a recent big hot vulnerability, we're tracking a lot of different malware distribution servers, and we know from our telemetry within AWS that we've prevented 103,000 plus malware installation attempts on AWS resources just in October. So that's pretty cool. The last one, which is a little bit more exciting, in terms of protecting customers from actually active exploits. So active exploits are rapidly, active exploits rapidly compromise systems by leveraging unpatched or unknown or new emergent vulnerabilities. So MadPot, though, emulates a plethora of different vulnerable technologies to identify and analyze these emerging threats, which enables AWS to proactively disrupt these active exploits. So how does AWS know that we're protecting customers? How do we measure that efficacy? So say you have two actors, actor A and actor B. Actor A is mitigated, so we know about their infrastructure, and so customers are protected by it. Actor B might be a new actor that we haven't seen before, so they're not mitigated. We run MadPot both unprotected, meaning the way AWS, how do I say this? Unprotected, and then we run MadPot protected with the same protections that every customer on AWS gets. And what we can see then is the not mitigated one, the source that we've never seen before, is able to hit MadPot with its exploit, both protected and unprotected MadPot. And then the mitigated one is blocked. So if we then compare these two kind of sets of MadPot, one in the protected VPC, one the unprotected, we're able to say a measurement of what percentage of customers then are protected. What percentage of threats are we blocking? So I'm going to go into now a little bit more exciting exploit. This was CyberPanel, a zero-click pre-auth RCE. Zero-click meaning there's no interaction required from the user. Pre-auth meaning pre-authentication, meaning you don't need to be authenticated on the system in order to get access to it. I have the CVS score up here. I think it's a 9.8. And CyberPanel, by the way, is an open source web hosting control panel. So you use it to help manage your servers, I think via like a web app or a GUI. On October 29th, CyberPanel was found to have a pretty severe vulnerability in one of its exposed endpoints. It was the upgrade MySQL status endpoint of the Django app, and basically allows you to bypass authentication and execute arbitrary commands. Again, result of improper user sanitization, user input sanitization. So within a day of this threat, though, Sonaris, so that other team we talked about that does a lot of inbound blocking, was able to take MadPot data and had a live mitigation for this CV that blocks actors exploiting this CyberPanel CVE for all customers across the network. So we heard about the vulnerability. Within the day, we then had the specific mitigation for that vulnerability. However, this graph might be a little confusing, but you can kind of see on the right graph tracking the CVE's traffic to the unprotected group. We were already protecting customers from the CVE because threat actors were not recycling their resources for it. So we already had them tracked, which gives us kind of this defense in depth advantage here. So again, the left graph, we have our protected MadPot. On the right, and these are requests for this exploit. In the right graph, we have the unprotected group. This is the group all you guys are in, which is cool. So ultimately, we're able to say in 2024, these perimeter protections that Sonaris does this cool work in resulted in 80% fewer exploit attempts against customers. So I'm going to talk about the shared responsibility model for a second. Amazon operates on this idea of the shared responsibility model of the cloud, where AWS is responsible for protecting the infrastructure that runs in AWS. On the other side, there is security in the cloud. Y'all are responsible for maintaining proper configurations and ensuring services are secure. So this work that we're sharing today is the way Amazon Threat Intelligence kind of raises the bar of security of the cloud. We're allowing customers to use higher level services plus our security services to get more and more for free. So in this presentation, we're kind of showing how we're leveraging the global scale of MadPot to place perimeter protections that benefit all customers against emerging indiscriminate cloud threats. We're effectively like removing the floor noise, the internet noise, allowing customers to focus on that narrow traffic that's really just affecting them. So this allows you then to do your own kind of threat intelligence here. Having said that, there are other ways to consume MadPot intelligence. So one way is in AWS WAF, AWS Web Application Firewall. We have what's called an AWS Managed IP Reputation Set in the Amazon Managed Rules. So these are the IPs that we're seeing hitting MadPot. These are the suspects. I really suggest you turn this on if you're using AMR. It's kind of a quick win. I would talk about the other ones right now. Like I did a lot of work in the AWS Managed IP DDoS list. If you want to stop DDoS, and we can talk about that afterwards. These lists are pretty much actively updated a lot. And they're a really cool feature with WAF. Secondly, if you're using guard duty, you can enable guard duty to receive MadPot intelligence on findings and alerts. So we have two categories of suspects we feed to guard duty today. I believe one is on command and control backdoors. So if any devices within your VPC or network are talking to these C2s, and that's not just, again, the suspects. If we go back to the whole chain, that's not just the guys probing your network. These are the guys that have the dedicated infrastructure if you're trying to talk to them, as well as Bitcoin crypto miners tracking on these. As a guard duty customer, you can configure these alerts. And if you aren't already a guard duty customer, I believe you can try it out for like 30 days and see what's hitting your network. And we're working on other features, integrations to get this out to you guys. But yeah, I think that's it. Thank you guys. If you have any questions, I'm probably going to take them off stage because I'm nervous about saying something dumb on stage in the recording. But thank you guys so much. Have a great day.